In this video, I will explain the solving strategy that can be used for drawing the products of free radical allylic halogenation reactions. Normally, alkanes react with X2 in the presence of heat or light to give so many products, but one of them, or the major one, especially if we have bromine, will be this one. So we simply just substitute one of the hydrogens, and it could be at this carbon or at this carbon. Those will be the major ones, but they also could be at any other carbon. Now, if this system was allylic, then the halogenation will specifically take place at the allylic position. And similarly, as in the case of allylic alcohols or allylic halides, two products could be obtained. The first product could be obtained by just substituting the hydrogen at this position, at the allylic position, by X, and the second product is obtained because of resonance by moving the double bond to be again between positions 1 and 2, and then X will be at position 3. So we will use the same strategy as in the previous video by numbering our allylic carbon with number 1, and then the double bond will be number 2 and 3. So for example, let's say we were given this compound and the reaction was Br2 and heat. To draw the product, so this will be the allylic position. Let's assume for now that they don't exist. So this will be the allylic position, and we have a hydrogen here. So now this is a first product, position 1, and then I will move the double bond to be between positions 1 and 2, and this will be at 3. Now in this case, of course, those two products are actually the same. Sometimes we may have more than one allylic position, and they could be similar or they could be different. They could be both. We could add bromine or chlorine to both positions, sometimes not. So it really depends on the structure. For example, let's say we were given this compound. Now we have two allylic positions here, this one and this one. This one, which is here, doesn't have hydrogens, whereas this one has hydrogens. So the reaction can only take place at this top position, top carbon. So let's say we have Br2 and heat, and this will be carbon number 1, so this is 2 and this is 3. In this case, first bromine will be here, and then after moving the double bond, so this is now 1, 2, 3, I will add bromine to position 3. Sometimes we may have more than one allylic position, and in this case there are multiple products. So for example, in this case here, if I'm doing a bromination or a chlorination reaction, this could be the allylic position, and so this will be carbon number 1, carbon number 2, carbon number 3, but also someone might say that no, this is actually number 1, this is number 2, and this is number 3. So in reality, the reaction will take place at both carbons, and that's why we will get two products here and two products here. And sometimes we may have even more than two possible allylic positions, and several products could be obtained. Now sometimes if you have something which is called a double allylic position, which is a position that is allylic with respect to two double bonds, then this will be the favorable one. For example, in this case here, this is an allylic position, this is an allylic position, and this is an allylic position. But this one, which is here, is actually called double allylic because it's allylic with respect to this double bond and this double bond. Whereas those two are not double allylic since they correspond to only one double bond. In such cases, the favorable or the major products will be obtained by substituting the hydrogen at this carbon. That's why if I have to draw the products of a bromination reaction here, then the first product will be just replacing this hydrogen by a Br, and this is 1, 2, 3, and you can also now either move up or move down. This is not going to change your product, so moving in both ways will be the same. And in the second case, the double bond will move here, and then Br will be at this position. And this is how we draw the products in such cases. Again, the products here follow the same order, which is tertiary, secondary, primary. So that's why, for example, in this case, we have a primary product versus secondary one. The secondary will be major. Here we have tertiary versus secondary. Again, the tertiary will be the major one. Remember that this reaction follows a free radical mechanism, whereas in the previous cases, which are the reactions of allylic alcohols or halides, the reaction follows a carbocation mechanism. Also note that NBS, which is N-bromosuccinamide, can be also used instead of Br2 and heat. So in all these reactions, using NBS with heat or Br2 and heat will give the same products.